先ほど申しました自然現象には本質的な不確定性があるにもかかわらず、そういうものがあってもですね、そういうものはあたかもないかのごとくやれる。これは非常に確率論的な手法を非常にうまく使っているということです。例えばそういうことのどういうものを使ってその制御能力が大きくなって、不確定な自然という部分があるにもかかわらず、それをあたかも確定しているように使っていくことができるように、まあ奥さんいく話してもよろしいけどね、もっとよくわかるのは選挙の時を見ますと、選挙の時にはですね、選挙速報値があるわけですね。当選確率ってことを言うわけですよね。まだ全部投票し終わらんうちに当選確率で、非常に不思議ですよね。当選確率なら当選確率と言わなくて当選と出るはずなんです。当選確率と出るっていうのは不確実だから確率です。どういうことか。その意味は何かと言いますと、どれぐらいの確率か分かりませんけど、非常に 100% に近いといろいろ推定をいたしまして、いろんな情報を集めまして推定いたしました。まだ投票終わってないけどです。あと投票してもですね、これ当選しない確率は非常に小さいだろうと。どこまでであるか知りませんよ。95% か 99%、その辺は私には分かりませんけど、非常にもう1に当選の確率、非常に1に近くなっているところで当確とかを出すわけですね。だから当確はたまには外れるわけです。めったに外れない。だから当確なんです。我々人間が生きてるということは本当はですね、毎日毎日生きていけるというのは、毎日毎日当選確率で起きてるわけですよね。そうですよね。今日も自動車に引かれなかった。だから私に引かれなかったからここにおるんだよ。明日引かれんかとそんなこと分からないです。しかしまあ多分引かれんやろうと。で、朝行きながらかどうか。行きながら確率は非常に大きい。その時は当選確率。そういう状況の中をずっと生き続ける。そういうもんですよね。大昔中国では、老子とか当時とかいう大変面白い人があるんですけど、人間っていうのはあんまり賢くないのはよろしい。バカの方がいいっていうようなことを言う。そういうこと言うけど、老子当時自身は自分はバカだと思ってなかったに違いないですよね。そこに矛盾がしてねある。それからこういうこと、老子はこういうこと言ってるんですね。知るものは言わず、言うものは知らず。ところが老子の書いたものが残っとんじゃないですか。言うとったんですよ。そういう矛盾があるけれども、明らかな矛盾があるけれども、しかし非常にそれはですね、その当時はどうであるか知りません。今となってみてこれからの世界というものを考えてみますと、恐るべき真理がそこに含まれているわけです。つまりいらんことをしたからです。一生懸命科学など進歩させたから人間はこんな偉いことになりそう。自分たちがお互いに人間とよくそこの底まで知るということを恐れなきゃならない。
As we all know, Hideki Yukawa's father was Chinese historical geography teacher Takuji Ogawa, and his older brother, with whom I read many books, is ancient Chinese historian Shigeki Kaizuka. Then there is Yukawa's younger brother, Tamaki Ogawa, who specialized in Chinese literature, so of course, Yukawa was not only familiar with writing calligraphy, but also Chinese literature, Chinese thought, or more broadly, Asian thought, and was a fan of Chinese poetry since he was a boy. I think he was taken aback by Lao Tzu and Chuang Tzu's so-called Taoism. Following this, Hideki Yukawa first theorized about elementary particles, and I think it is evident in how he focused on the Lao Tzu, Chuang Tzu thought found deep within Basho's haikus. As Hideki Yukawa was skillful at tanka, which is short lyrical poetry, where in the middle of its profundity there is what one might call the measure, which is a measure of the meanings that are sung. And of course, many of the songs grasp his own true feelings. Take the following song, for example. walking along the line of defeated warriors, looking for a brother, longing to see him alive. A dog crouching, a frog croaking, wandering down a road of darkness and shallowness. An elderly lady shows me to a deserted room. On a silent tatami mat, a marten poops. So over time, Hideki Yukawa advanced to the third high school of Kyoto University, or what was known as the third high school back then, and despite, of course, having an interest in science and physics, he kept reading Kitaro Nishida. Also, around the time of Yukawa's entrance into the third high school, Nishida was lecturing weekly on introductory philosophy, which would go on to become Nishida philosophy. And Yukawa gained an interest in his lectures as well as those of mathematician Kiyoshi Oka in differential and integral calculus. What I thought was amazing about Hideki Yukawa was, aside from his scientific results, how the East and science and his father's influences, as well as his rivalry with his brothers, allowed him to read tanka, write calligraphy, and tie it all back to science. I get the feeling, to put it another way, that as a scientist, Yukawa could pick up on things that ordinary scientists would not have realized. One instance of this was Hideki Yukawa's strong interest in Buddhism, when he would ponder about what Buddhism was. This being a vital part of living in Kyoto, it was amazing that Yukawa could see that his views of Buddhism, or science and mathematics, were missing something, and that this meant there was something lacking within himself. On the occasions that I visited the late Yukawa's home, I would inquire into his thoughts on Buddhism. As written by Hideki Yukawa in his later texts, he basically pondered many things such as what was missing in his own Buddhism theories, how his perception of Buddhism was limited to impermanence or Jodo Buddhism. It was enhanced by Honen or Shinran as parts of Japanese Buddhism, which led to the concept of Namu Amida Buddhism and Jodo. Yet he took another look at Buddhism and found a different Buddhism, like Zen, which was nothing new to Hideki Yukawa since he had already heard of it in Kitaro Nishida's lectures. But there was also esoteric Buddhism. There was something quite special about esoteric Buddhism as a part of Japanese Buddhism. And despite it being ignored in the Meiji era, Hideki Yukawa focused his attention on Kukai, as he believed the esoteric Buddhism as a train of thought within the Japanese way might be a highly unique part of how Japanese people think. It would be strange for Jodo Buddhist scholars to suddenly turn to this point of view of Kukai. It would not be easy for them. For those practicing Zen, it would be difficult to move on to Jodo, as well as Kukai. But as a scientist, Hideki Yukawa constantly pondered what was lacking within himself. This engrossed him. He went through the ingenious works of Kukai to find what was lacking within himself, and while immersing himself in Kukai, he felt something was missing in European logic and logos, as he studied theoretical physics, science, and of course most importantly logic. Due to this dissatisfaction, he came in steady contact with and focused on the philosophies of a Japanese intellectual named Bayan Miura, who would be known as a scholar of reasoning following the mid-Edo era. And Yukawa set out to discover what was missing within himself through Japanese thought, Buddhism, and logic. For quite a while, I had forgotten Lao Tzu and Chuang Tzu's philosophies. 4 or 5 years before, I recalled studying Chuang Tzu for a moment while thinking about elementary particles. Then I thought within the elementary particles there must be undifferentiated parts among the various elementary particles that have not been differentiated. At that time, I thought if there was any word that I knew that described this, it would be hundun. Normally, a theoretical physicist would not apply hundun in such a case. There was a time when I would ask the late Hideki Yukawa about his theories of measurement. In measurement theory, you need at least one photon to be able to see the smallest particles, which means you need to shine the smallest light on the smallest particle in order to see it. And in fundamental measurement theory, this means the smallest particle itself is disturbed by the smallest light, and therefore unidentifiable. However, I took this to mean that science will not progress any further, and when I approached Hideki Yukawa with this problem, he said the following. It depends on how you view the difference between what you see and what you do. If you stay focused on that difference, science will cease to progress. Nothing will happen. What you see with, what you plan on seeing with, is what is important. What you have is here and what you see is over there. And you have to do both. When you do, you have an idea of what it is you have and you see when you are looking. For example, if you are looking at coffee or a woman or that tree over there, if you do not think it's a tree, then it's not. And if you look more ambiguously, it's a town. So regardless if you are looking here or over there, with what you regard both respectively act together. And you need a science that continuously includes both of the ideas. With this, he told me that a new theoretical physics must aspire to this. And after that, he wrote this tanka. Be land and sky, a voyage or lodge, birds and humans come and go.